Welcome, engineers. My name's Travis IQ, and today we're going to talk about patio furniture. No, today is our day 2 or part 2 discussion of IP addressing, logical addressing. This is a follow-up to our discussion of physical addressing. Right. So logical addressing is the addressing virtual assignment of addressing. Right. So logical means defined in software, which means it's not burned in. The device receiving the address doesn't know what address it has if it were to log onto a network and need to communicate. Right. So these things need to be assigned. And our classic example of logical addressing is IP addressing. IP addressing, Travis. Let's have this discussion of IP addressing. First and foremost, what is an IP address, right? Our IP address is a 32-bit address. Made up of 4 octets. This uses base 10 addressing. Of course, I am talking about IPv4. Which is probably the IP address we are most familiar with, if you're familiar with logical addressing, right? There is a new IP addressing standard, right, which is not new now. It's been out for 10 years, but is still not particularly mass adopted in the residential space, which is 128-bit address using hextets, and it is hexadecimal addressing, and this is IPv6. I am not going to talk particularly about IPv6 just because I don't have time to do both discussions in this one video. So let's save our discussion of IPv6 and IPv4, the differences, for another time. There are a number of differences and they're very interesting, but for now we'll talk about IPv4. IPv4, logical addressing. What does this mean? Remember I said at the beginning here that our host, let's say PC1, doesn't know what address it has or it should have when it joins a local segment, local subnet. Okay, this is unlike our physical addressing like we discussed last week where our hardware address is burned in, so I already know what my address is. Okay, so how do I get an address? Well, there's really 2 ways, right? We can do this dynamically through something like DHCP. This is Dynamic Host Configuration Protocol. Or static. And as static would infer, right, this means set by you, the administrator. There are a couple other ways that we can maintain IP address consistency, or you can do like address reservation and things like this. But let's just say DHCP is dynamic. I ask for an address. Hey, can I get an address? And a DHCP server gives me an address in the range of addresses that it is assigned to dole out. Or static, where I say, here is your address, and this is the address that you always have. Traditionally, right, users who log in and log off and these types of things would have dynamic addresses, laptops and things like this, phones in wireless environments, and utilities that are used regularly will have dynamic addresses. Again, vast overgeneralization, but still pretty useful. Things like servers and printers and DNS servers and things like this. Right? Okay, what do our addresses look like, Travis? What do our addresses look like? So I said it was a 32-bit address with 4 octets. 192.168.1.1. These are octets. And there are 4 of them, and they are represented by 8 bits apiece. I am not going to go into binary conversions, base 10 to binary conversions right now, but we will absolutely do this. But they are represented by 8 bits apiece. If you think about that, 8 and 8 is 16, and 8 and 8 is 16 is 32. So this is my 32-bit addressing scheme. 32-bit addressing scheme. You might oftentimes see this in conjunction with something like a subnet mask, So address and subnet mask. And the subnet mask defines who is local to you. I know we're introducing a lot of concepts here. These are things that I need to talk about at a later date, but this is oftentimes what you'll see. And so this would be identifying the network octets, right? And this would be identifying the host octets. So this is host addresses, so 1 to 255, and this is the network that I'm on here, the 192.168.1 network. Again, if you remember, I talked about locally significant only for our hardware addresses. That is not the case for our logical addresses like this, right? These can be globally significant. The address I've given you here is a private address, so probably not globally significant, right? But if I gave you a global address, 204.4.24.11, right? This is a global address. That means it identifies you in the world. It means that it's a way I can send you information, send you messages, send you stuff, right? If we think about our equivalents for physical addressing and logical addressing, I would say that a logical addressing equivalent would be the equivalent of your street address. That's how I get you packages, right? And your physical address would be the equivalent of your first name. So if I were to try and send you, person out there, a package to Susan, the post office would go, I have no idea where to send this. It's the same thing with a MAC address, right? Our router's going to go, I don't know where to forward this. This isn't the type of information that I look for. If I were to send you a package to your street address, Boston, Massachusetts, a numerical address and street number, these types of things, right? The post office would go, oh, I know where to forward this. Your router would route that traffic appropriately. This is why this is globally significant and your physical addresses are only locally significant. This is also why we need both locally and globally significant addressing schemes. Cool. This introduces a lot of stuff that we need to talk about in upcoming and subsequent videos. And there will be some longer videos where I talk about these addressing schemes and breaking down subnetting and the way that I like to teach and understand subnetting from an instructor's point of view. But for now, this is that second part of this video that I promised, and here it is. As always, engineer, break stuff, and have fun. If you liked the video, like and subscribe below, and we're just going to keep pumping out content. Let's do it.